a little bit about binary numbers and Python's bin function. Also, Python's right shift and left shift. Let's talk about this. So I have an x variable, we're going to hold the integer 9, and the y variable, we're going to hold the integer 19. Now I'm going to convert these numbers to binary, and Python has this built-in function called bin. Bin parentheses, pass in the integer that you want to convert over to binary, and we're going to stuff that string representation, that string binary number in this x bin. So what does that look like? Well, let's print this, and I'll go through my code and I'll show you exactly what I mean. So the first thing is x equals 9 is what we're printing here, and we're going to show what is the x bin. Well, the x bin is this value, and in Python this binary function is going to give you 0b just to indicate that the following digits are a binary number. So really these are the binary numbers, right? 0b is going to be the prefix for everything that comes back from this bin number. So let's decode this 1001 here. What's the big deal here? So just a quick overview about bin numbers, binary numbers rather, is that we start from right to left, and from right to left we start with the number 1, and then 2, and then double 2, well it's 4, then double 4, it's 8, and double 8, it's 16, and so on and so forth, 32, 64, 128, and so forth. But I'm going to stop at 8 so that we can keep it simple. So what does that mean? For 9, we have 1, 1, we have 0 2s, we have 4, we have 0 4s, we have 1 8. So if we have 1 8, that's 8, and we have 1 1, so 8 plus 1, it's equal to 9. That's what happens here. So we have 9. That's the big deal here. Now, if you didn't want this, by the way, if you didn't want the 0b, one thing you could do is when you get this binary x, right, when you invoke this binary function, you can just say parentheses 2 colon, and that's in a slice starting at number 2, the index number 2, which is going to be this index here. This is 0, 1, 0, 1, and 2, starting at 2, which is this 1 here, if I can highlight it, at 1, and give it to me all the way to the end, which is what this means. The colon's nothing means, hey, the default is give me all the way to the end. It should give me 101, right? 1001 rather. So that's what you could do to remove the the 0b, and you can do that by doing something like this. And that's exactly what we get here. We removed that. So I just wanted to show you that you could do that with slicing. And if you're not sure exactly what slicing is, take a look at my slicing video, and you can see how we can slice strings, and we could also slice collections like tuples and lists and so on. So definitely take a look at that. What else? What am I doing here? I'm just formatting this 8421. Right, justifying it with 6 digits. We know that. What else am I doing? Well, I'm just showing what y is here. Y is basically 19. And the same thing happens with 19. If we do the same exercise, we can say, well, there's 1, 1, there's 1, 2. I mean, there's 2 2s, right? I'm sorry, there's 1, 2, there's 0 4s, and there's 0 8s. But we know that there's 1 16, because there's a 16 here. If we double 8, that's going to be 16. There's 1 16, so 16 plus 1 2, right? 1 2, it's 18, plus 1 1, that's 19, and that's how we get the 19 here. Just to highlight how we get those numbers. And lastly, I just wanted to talk about, the right shift and the left shift. What does that mean? Well, let's take a look at here. If you have x, right, and we have x here, and if this is x, when we print the binary of x, it's going to be 1001, and if we right shift, right, by just 1 by 1, that means that we're going to divide the number by 2. Why? Because we said this would be 1 1, 0 2s, 0 4s, and 1 8. So this is a 9, right? 9, and if we shift by 1 to the right, that number in binary, it's the following. And that means we have 0 1s, 0 2s, and 1 4. So we divided 9 by 2, and it is 4. And that's what we get with this binary string here. So the same thing happens if you left shift, well, something similar, not the same thing. Something similar happens if you do a left shift on this number 9, because you're going to multiply it by 2, right? If you right shift 9 by 1, you're going to divide by 2. Well, any number, if you right shift by 1, you're going to divide by 2. Any number, if you left shift, you're going to multiply it by 2. And that's exactly what we get here. So, for example, at the beginning we have 1 1 and 1 8. That's 9. So we know that the doubling of 9 is 18. And let's see what happens here. So there's 0 1s, 0 1s here. Oops, 0 1s here. We have 1 2, 1 2, and 4 0, 8 is 0, 16 is 1. So 16 plus a 2 is 18, and that's exactly what we get when we multiply 9 times 2, or we double the number 9, the integer 9. Lastly, I just wanted to show you, and this is how we'll finish the video, is that you can take x and like this is a hexamal, and you can convert a hexamal to an integer by passing the base. So if you do something like this, we know that we get 35,723. But if you wanted to take the binary of x, and you know that this is base 2, we know that's base 2, we should get a 9 back. And that's what we get here with this last print statement. So again, the int, we've seen it before in other videos where you can cast a value to an integer. Well, this is converting a value to an integer, but we're giving the base. And you can give this a 2, an 8, a 16, whatever the case might be. We know that computers think in binary numbers, zeros and ones, and you can see how it's easy for the computer to divide and by 2 or multiply by 2. It's much easier than doing a computation. Just by a simple shift, we can get a lot of computation efficiency. And so that's the way computers work. But that's not the way that humans think, right? We have 10 fingers, and that's why we have 10, we have decimal numbers, right? We count up to 10, and then we continue from 10, right? 1 to 2, 3, 4, 5, 6, 7, 8, 9, 10. It's because we have 2 hands, and each hand has 5 fingers. So there you go with the decimal numbers. I hope this makes sense.